So hello again, it's Stephen. So continuing on my thoughts about this idea of many worlds, this physical theory that says that in the quantum world, if you make an observation, of a quantum event, that that event goes from being a probability that exists in the world to being the world becoming the probability of the choice that the observation showed. So you observe a quantum event. When you do, you get an answer. And then the universe literally divides itself into several universes, one for each of the probabilities of the possible observations. So you now are living in a universe based on the probability of the observation that you observed. And there are other observations that could have been observed, and those universes also continue to exist. So that it's true. I mean, it's if you look at what we know, and what we know is a fair amount here. We have a theory, a mathematical formula that's extremely accurate that says this is what happens, and the only way to get around this idea that observation of a quantum event produces multiple universes, the only way around that is to introduce pieces into that formula that don't seem to naturally occur. So we talked about that in the last video, that one way of doing it is there's things introduced that you don't know about. And because of those things, even though it appears as though there was only a probability that you saw that, it was actually not a probability. It was for sure you saw that, because there was information in that quantum event that you don't know about, we don't understand. And then the other is that we add math to that equation, and by doing that, we end up with the reality that we see being the only universe that proceeded, even though it was a probabilistic event. So we can either have information in there that we didn't know about, or information that we threw in. But if you say, well, the equation, it's called the Schrodinger equation. If the Schrodinger equation predicts this happening, and its accuracy is the most accurate predictive device in physics, then probably why do we need to add other things? Why not just go along with it, and until there's some insurmountable problem? So you might say, well, there's an insurmountable problem. How can all these universes exist at the same time? Every time we measure a quantum event, there's multiple universes that come up, each universe having the probability of the event having a certain outcome, and we're on in the universe where the outcome was the one that we saw. It's crazy, right? But then if you do the math, you figure out the number of degrees of freedom, the number of possible ways of configuration of quantum states. How many universes can there be based upon these degrees of freedom needed for the universe to exist? You find that there's this thing it's actually called anti-de Sitter space. I call it de Sitter space. And in that topography, then in that mathematical version of space, no, there's no problem. We can accommodate all these universes, and so but these universes can never interact with each other. That's a caveat, is that these universes, you cannot get to the other one. So this is not like science fiction where we can play with interactions between the separate world, the many worlds. In the case of physics, in the case of what we know, there can be no interaction. They're literally separate universes that you can never observe them. So that, I guess, that helps in a way. We don't have to worry about ever interacting. It's never going to happen. So this has led to a lot of speculation. Well, what's so special about an observation? So why it only happens when you observe it? If you don't observe a quantum event, then it goes on as a probability of, and we don't notice it, and the universe exists in this multiple states at once, and it just goes on with this, with the probabilities. But if you observe it, all of a sudden it looks as though your observation is yes or no, and that's 100% or 0%. We're no longer in a probabilistic situation. So, but then Schrodinger equation says no. You're still in a probabilistic situation. You just are existing in the universe that has the outcome that was the probability that you observed. So. That's led to a lot of speculation. What is this observer effect? What's so special about the observer? Because you have to observe the quantum event. And I think the first observation of a quantum event happened in 1801. But we've observed a whole lot of quantum events since then. So we've generated a lot of universes. There's been speculation that it's a psychological thing, that there's a psychological field of some sort, and that psychological field of observation of us looking at the observation causes causes that probability to become one. And so there aren't multiple universes because there's this extra thing. That's, as I was saying before, it's always either this extra thing that you know about or this extra thing that you don't know about. This is kind of a subtle combination of both those ideas, this psychological idea, but it doesn't seem to be. I mean, it's just complete. There's no evidence. There's no evidence at all. So I don't think we'll think about that too much till there's evidence. So what is it about the observation? And part of it is that the experiment you build to observe becomes a part of the system of the quantum event. So the quantum event exists in a world and is affected by things that are going on in the world. And so you try to isolate the quantum event to study it, right? To observe it, you want to isolate it, but the problem is that you are attached to a machine, and the machine is entangled. They call it entangled in the experiment. It's too close to the quantum event to not become a part of it, so that the probability becoming yes or no has something to do with the machinery, But if you're not there to observe, if you're not there to study the data, what is it? Is it real or is it not? That's the mystery about it. This is sounding very much like a theological problem, isn't it? It's sounding very much like there's an observation of some very mysterious sort going on, and it has been happening with human observation since 1801, and. So I think I'm going to try and build this into a theological argument for Christianity, and we'll see how that might be done. But it's going to be done. I'm going to proceed along this line of our observation is not just us, that somehow the divine, the uncreated universe, that created that situation of quantum event and observer, that creation of that event had something to do with man, that we're special in a way, and that we were created partly to be able to see this quantum world, and to see it in a way that sort of boggled our minds. This is how are we ever going to understand this thing? is this thing ever even going to be an understandable thing? So entering a sort of a theological space. So anyway, that's the next thought's the observer issue, and I'm gonna use that observer issue in the many worlds space to proceed with a theological argument. So next time, thanks.